Okay, finally, we are going to look at the intersection of three planes. We're going to go over 5 different cases. Even though there are more than 5, these 5 should be sufficient in helping you navigate all of the other iterations of the cases. So for the first one, well, all the time, we're going to first evaluate the normal of each plane. So this plane here, oops, just going to zoom in a bit. All right, so this first plane here is going in this direction, 1, 1, 1. The normal of the second plane is going in the direction 2, 2, 2. The normal of the third plane is going in the direction -1, -1, -1. So this is really my first clue for what's going on between these 3 planes. And what I need to do now is so now I know that these planes are going in the same direction. So there are 2 options left. Either these are the same plane or these are parallel planes. So I'm going to take a look at the full scalar equation, and I'm going to see that this second line, plane 2, is actually twice as big as plane 1, and plane 3 is actually the negative of plane 1. So therefore, the scalar equations are multiples. This means that these are coincident planes. These are just the same planes. Okay, let's look at this example in comparison. Okay, so I'm going to look at the normals. I've got the normal 1, 1, 1, second normal 2, 2, 2, third normal 1, 1, 1 again. Well, these planes are all going in the same direction, but are they the same plane? Well, in order to go from 1 to 2, the direction, the scalar, the direction of the normal has just been doubled. It's been multiplied by 2. But when I look at how far away it is from the origin, I can see that it is not twice as far away from the origin. It's 4 times as far away from the origin. So therefore, these planes, the normals are multiples, but the scalar equations are not. So these planes are just parallel. Okay, they are not an equal distance. Sorry, to the origin. All right. So those 2 cases are pretty easy. And we always want to eliminate those 2 cases because we don't do a bunch of work just to end in the result that they were actually parallel or coincident. Okay, so let's look at another example here. Okay, so first, again, I'm just going to quickly look. 1, -1, 1, -2, 2, -1, -2, -9. Okay, that's definitely not coincident because no multiple there. And 3, 1, -1, -2. Okay, that's also not. So here I'm probably going to have an intersection of some type. Okay, so let's set up the matrix to represent these points. Be super careful when copying this stuff down because one missing negative can make a giant mess. Okay, so here is my matrix, and I am going to work at getting some zeros. First, I think I can easily get a 0 here, so I'm going to do that with my first line. In order to get a 0 there, I'm just going to go 1 plus 2. Okay, actually, I changed my mind. I'm going to go 1 plus 3. You'll see why in a minute. Okay, 1 plus 3 is 4. -1 plus 1 is 0. 1 plus -1 is also 0. And -2 plus -2 is -4. So I actually ended up with 2 zeros there. Okay, in line 2, I'm going to see, can I get, oops, I did not want to do that. Can I get this guy to be a 0? How could I do that? Well, I could do that by taking 2, take away 2 times 1. Okay, so 2, take away 2 times 1, that is 0. Negative 1, take away 2 times 1 is positive 1. Negative 2, take away 2 times 1 is now going to be negative 4. And negative 9, take away negative 2 times 2 is going to be negative 5. Okay, let's see, can I also get a 0 here? Can I do that as well in this first new matrix? And if I did 3, take away 3 times 1, that would be good there. Okay, so I'm going to go 3, take away 3 times 1, gives me a 0. 1, take away 3 times negative 1, gives me a 4. Negative 1, take away 3 times 1 is going to be negative 4. 2, take away 3 times negative 2 is going to give me positive 4. Okay, now that I have all of that, I'm going to move over. I'm going to want to get some more zeros. And actually, I'm going to start by turning that into a 1. I can do that just by going and multiplying everything in here by a quarter. I'm going to have 1/4 of 1. Okay, the next thing that I'm going to be doing is I'm going to try to get a 0 by taking 2, subtract 3, so I can end up getting a 0 here. So let's do 2, subtract 3. Okay, 0 take away 0 is still 0. 1 take away 4 is negative 3. Negative 4 take away negative 4 is 0. And negative 5 take away 4 is negative 9. So that's good. I got 2 zeros there. Can I get a 0 here? In order to do that, let's go 3 take away 4 times 2. Line 3 take away 4 times line 2. All right, 0 take away 0 is 0. 4 take away 1 times 4 is 0. Negative 4 take away 4 times negative 4 is going to be positive 12. And 4 take away negative 4 times, take away 4 times negative 5 is going to be 24. Okay, I actually can write my reduced echelon row here now pretty easily, but I also can just also know exactly what I'm going to end up getting. So line 1 is already in good condition. This line needs to be negative 1/3 smaller. The last line needs to be a 12th smaller. Okay, so my point of intersection happens when x is negative 1, y is 3, and z is 2. All right, let's look at another case. Case 4. Okay, so I'm going to quickly look to see if I have any parallel normals to eliminate that possibility first. And I don't, so I'm going to set up my matrix. Number out my lines so I can track my changes. And let's see what I should do first. Well, I'm going to get rid of, oh, geez, sorry. I'm going to get rid of this negative 1 here. And I'm just going to do that by adding 1 and 2. So I'm going to go 1 plus 2. 1 plus 1 is 2. Negative 1 plus 1 is 0. 1 plus 2 is 3. 1 plus 2 is 3. Next, I'm going to see, can I get a 0 here? And I could get a 0 there if I did line 2 minus line 3. So 1 minus 1 is 0. 1 minus negative 5 is 6. 2 minus negative 1 is 3. And 2 minus 1 is 1. Finally, let's see if I can get one more 0 in this spot. And I can do that if I do 3 minus 1. Again, lots of options here, and I'm just trying to eliminate the likelihood of making mistakes and carrying forward, so I'm using a variety of lines, and I'm not trying to create a duplicate. I don't want to like do the same thing twice, go around in a circle, so to speak. Okay, 1 minus 1 is 0. Negative 5 minus 1 is negative 4. Negative 1 minus 1 more is negative 2, and 1 minus 1 is 0. Okay, let's move on. We've got some good things happening there. Okay, so let's look at row 2 and 3. And let's actually, okay, so we're going to write back in row 1. I'm not going to change that. Let's see why in a minute here. Let's look at row 2 and 3, and what do we notice? So if we took 2 times row 2 and we added it to 3 times row 3, let's see what would happen. So I'd end up with a 0 here. 2 times 6 is 12, plus 3 times negative 4 is also negative 12, so that's going to be a 0. 3 times 2 is 6, plus 3 times, 3 times negative 2 is negative 6, that's also going to be a 0. And then I also am going to have 1 times 2 plus 3 times 0, that's going to give me a 2. Now, I'm just going to write in this last line unchanged. I'm just going to talk about this right here. Okay, so this means that no x's, no y's, and no z's equals 2. So this tells us that there is not a case, there is no solution, there is no case, there is no position for x, y, and z where we get a point of interception. Because we know that these planes are not parallel, therefore these planes will form some type of triangle. Make a triangle. Okay. All right, one more case. Case 5. Okay, so set up the matrix and label the lines 1, 2, and 3. All right, let's think about what we want to accomplish. We can maybe try to get a 0 in this spot because there's 1 and negative 1. That would be nice and easy without doing too many things. And we also want to get zeros here and here. In order to do that, all I need to do is add 1 plus 3. And then I can take 2 away from 3. And I can take 3 away from 2. Okay, so I did that. There's the answers. Uh-oh, it looks like we maybe have something similar to last time. So let's just focus on these 2 lines here. Let's just see what happens when we go 2 plus 3. Okay, so negative 7 plus 7 is 0. 5 plus negative 5 is 0. Okay, but 3 plus negative 3 is also 0. This line is valid. Oops, sorry. This is a good solution. Okay, all right, so let's keep going. Okay, so let's do, let's get some zeros in this spot. So in order to do that, I'm going to have to go 7 times 1 plus 2. There's 2 up here. And yeah, that's good. Okay, I'm out of time for the rest of this video, but I essentially set up these 2 expressions. I let z equal t, and I write my parametric equation of a line of intersection.